This is activity 9, and it says for this activity that you need to have balance. So I'm making sure. Oh, it says that you need an electronic balance. Well, that's different. Let's bring one on, and presto! There we go. Now we're set. All right. So this lab investigation is having students investigate what is happening during a chemical reaction, having them predict if a chemical reaction occurs and it's a closed system, is the mass going to change? So that's why we need the electronic balance. Let me go ahead and get that turned on. There we go. So for this, you're gonna need, it's the classic baking soda vinegar reaction. So we need to pour out half a cup, 118 mils. So I'm just gonna pour out just above 100 milliliters of this into my flask. That smell is amazing. Now, it says in the instructions that to use a soda bottle, those will work, but I figured I already had this flask out from the previous video. I didn't need to get something else out. So the other thing that we're gonna need is a funnel, and that's gonna help to get the baking soda into our balloon. The reason you wanna do that is when we go to do this, you can keep the baking soda here while you seal the balloon, and then you can dump it. And that's that makes sure the entire reaction is sealed and you're not losing anything during that reaction. The one thing that you want to watch out for is baking soda can clump and form kind of bigger pieces. So if you don't have a good funnel, or if you're not going to crush this, that's going to just clog. And so I went ahead and just used my spoon and kind of crushed up all the big pieces. So now we got some fine powder. Use the funnel, and let's go ahead and start pouring that in, and I hope I don't make too big of a mess. Seems to be doing good. Got that all in the funnel, and then you just kind of use the funnel to shake it down into your balloon. And if we don't get it all quite there, that is okay. Looks like I got a piece possible. Oh, there, we're still going. So just tell kids to keep tapping, and the baking soda will continue to go. Every once in a while you do get a little bit of a clog, but it's doing a good job. And nearly done. This is why I suggest the bigger funnel. This was the biggest one I could find on a short notice, but there we go. Now my baking soda is inside the balloon, and so then we got to seal it over the lid before we, I got one of the scales that takes a long time to load up. So what I'm gonna do is gonna do a jump cut so that this is ready to go once I'm ready to go. So see you guys right now. And we're back. Forget those small digital new age scales. We're rocking it old school. Here we are with a triple beam balance. Do kids even know how to use these anymore? Am I right? So I've got this guy balanced, so if there's any change in the mass, actually I should probably balance it with the balloon. Thinking ahead. And that way, the total mass is there. And actually I can put this on and balance it. You can tell how much I prepare for these videos, huh? Now the trick with the balloon is you don't want to dump your baking soda before you're ready. So now all that is on there and we are balanced. Doesn't need to be perfect, because what we're ideally looking for is that it doesn't change its mass. So it will kind of fluctuate when I dump it, but this has already taken a long enough time. So this might be one that you do as a demonstration, have a few student volunteers, so that way you just don't have to deal with as much. You can already see, and I'm gonna step over here. This is probably why they wanted this tall soda bottle. This seemed to do good. A lot of it went into the balloon, which is why it fell over. Woo! Okay, so that should get a pretty good reaction out of your students. And you can have your students feel both the beaker and the balloon after you've done the weighing. And you see I have a bunch of that in there. And now if I let it be, and the bouncing stops, we're still balanced. And so you should see maybe a slight change in the scale, but you can see he's still able to fluctuate. But I think I stopped saying it. But if you have your students feel this reaction as well, this is an endothermic reaction. It means it's pulling energy into it, causing it to feel cold to us. And so that will be a kind of another good thing that you can talk about, or bring that experiment back up when you do endothermic, exothermic. Okay, looks like I got a bunch of editing to do with this video now, so I'll catch you guys in the next video. Bye.